first, in this workshop, I will briefly and more intuitively talk about the as a Kickstarter to the project. So how can we start a research project, and what is exactly mean by research project, and how can we formulate such a project in our undergraduate career, as well as when we are going forward with our higher studies as well. So can you go to the next slide? Yeah, as Malli previously mentioned, I am Nuwan Bandara. So I am a final year student at ENTC UOM, following the uh, biomedical engineering degree program, and I am also working as an undergraduate researcher at Biomedical Research and Innovation Collective. So apart from my main studies in engineering, I'm also following law at Sri Lanka Law College, which is the established law firm, education firm in Sri Lanka. So moving on, today I will be covering these 6 topics in a more systematic manner. So first, I will introduce you what is a research problem, and how can this research problem be integrated with an innovative project, and what is the importance of a feasibility study, and what is the execution plan of your project, and then what kind of progress reviews and final demonstrations can you expect from a competition, for your academic study, academic course, and how to make your project into a publication, a research publication, uh, or a patent as per se. So and what kind of personal traits to self improve that I have learned throughout my career as an undergraduate, and as well as a researcher. So moving on, yeah. First, we would discuss about what is a research problem. So when you see these 2 words, issue and problem, uh, in their literal meanings, they will be the same. I guess most of you would think their meaning as same. However, in research, we see these 2 words in different formats, so different kind of contextual meanings. First, an issue is closely related to the background of the story. So as an example, I can say issue is kind of the superset, and problem, when it comes to the problem, it is kind of a more specific one. In research problems, uh, we would tend to address these specific problems. So uh, as an example, I can say, as an issue, the fast food consumption in Sri Lanka is high. uh, that in that case, the that is an issue, that is not a problem, because it does not contain any specific kind of measurement or a specific kind of information of what is the specific thing that the problem causes. So kind of health, is there any health issue, or is there any food issue or something like that. However, when from that issue we can derive several problems. So one thing is, due to this fast food consumption, high fast food consumption, the diabetics prevalence in Sri Lanka is high. So that is a problem, because as we all know, diabetics is an issue, is actually a problem, health problem. So it's kind of one of the most prevalent non-communicable disease in the world. So it is indeed a problem. So first you have to understand the context of the issue and the problem. When it comes to the issue, it mainly deals with the background, and problem is more specific than the issue. So then throughout my presentation, I would use the word research. uh, I will use that word in a more literal manner. The literal sense of the word research is investigating systematically. So I only based on that definition, I would use the word research. it is not related to any academic kind of research as per se. I just use that word for meaning the context of investigating systematically. So when you are selecting a problem, you have to uh, yeah, you have to select a passionate area. So most of the times uh, we are kind of uh, stuck when we are kind of dealing with what is my passionate area, how can I find my passionate area. uh, so many questions are arousing. So uh, I what I believe, as per my experience, the passionate area basically comes with your when you are going forward with your studies, when you are going forward with your going deeper with your studies. You would find several subjects and several courses modules in your curriculum. So you may find something interesting, some subjects interesting than others. Most of the times when you are going deeper into those interested subjects, you find you basically find your passion. So what you have to be is be consistent and find what are the subjects or what are the modules that you most that you are most interested in than others. So yeah, uh, that is one thing. That is one thing about finding the passion. So and so when you find your passion, you have to explore the current trends and problems of your passionate area. So as the main three ways to find the current trends or problems in your passionate area are these following things. So you can either read research articles, patents, or blogs or reports, or as per se. So most of the times, this is the most I would say the most encouraging one to. So yeah. uh, yeah then you can attend to conferences, forums, and workshops. Most of the times as undergraduate, you can also attend these conferences. Most of the conferences, they provide waived fees for undergraduates, and you can directly communicate with your expertise persons within your department, such as your lecturers, PhD students, or industry personnel. So the problem identification part, I would say it is the most important part. As per my experience, what I mostly spend my time on a project is identifying the right problem. Because if you are not if you cannot identify the right problem, then if the first step is wrong, then all the other subsequent steps are deliberately fault. So most of the times I spend a lot of time in going through the research articles and attending conferences, so communicating with lecturers to identify the most important research problem. So sometimes the idea may come from those expert personnels as well. So they will since they are uh, more conjunction with the ongoing research trends and problems, they have more insights than you. So what I recommend is go communicate with your expert personnels, lecturers, if you want to build up your understanding on a research problem. Yeah, moving on. Then you're into developing a innovative project. So first you have to understand what is invention and innovation. So normally invention is something you are developing something totally new to the world. But that does not necessarily mean that you are kind of developing something that has a commercial value. Most of the times, the inventions that are developed uh, are, are 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 having less commercial value, so they lack the commercialization procedure. So invention is something totally new, but that does not necessarily have the commercial value. But when it comes to the innovation, it is something new, but it has some commercialization value as well. So yeah, so first you have to understand what is invention and innovation, and then what I can say is an innovative project is kind of a passionate commitment to solving the identified research problem. So when it comes to the passionate commitment, since you have found a research problem in your passionate area, so you're passionate into solving that pressing problem in that particular area. So apart from that, you are going to solve and identify the research problem. So uh, I believe that is the most important definition that I can say for an innovative project. So you're passionate and you are committed and you are going to solve the identified research problem. So then when it comes to solving the research problem, you have to identify the objectives of your research problem and your methodology. So I think, yeah. So then when identifying the objectives, you have to deliberately and collaboratively identify the scope as well. So objectives and scopes, most of the times people tend to believe that, or most academics also tend to believe that these are the same words, so they literally mean the same thing, but they are two different things. Scope is kind of the boundaries of your solution. So you cannot in one particular project you cannot solve all the questions in that particular research area. That is the same. So the scope defines the boundaries, and when it comes to the objectives, it is kind of the critical milestones that you are going to solve through your methodology or through solving your identified research problem. So next thing is the one of the most important thing when it comes to a research problem or a kind of a research project is the feasibility study. I will explain this thoroughly in the next slides, and then you have to your project or innovative project should be outlined on an achievable time frame and insights. The insights may come from your expert personnel, lecturers, or PhD students, or as per se. So you have to build a revised timeline. You may revise that throughout your project. That doesn't matter. It is totally normal. Uh, when we are doing projects also, we do kind of modify the time frame again and again. That is totally normal. However, you have to have when it comes to a academic project or a competition, you know that there is a particular deadline, so that deadline should not kind of violate. However, within the available time period, you can adjust. So one of the most important thing that I want to emphasize is when it comes to the research projects, and they should not be centered upon getting popularity or achieving high distinctions. As a researcher or as a particular scholar, you need to have a kind of a enthusiasm to solve the pressing problem rather than getting popularity or getting kind of high distinctions from your project or from your results. So it should not be concerned about your normally it is concerned about your, when it comes to academic project, it is concerned for your academic transcript, but your objective of doing that project should not lie upon that. And sometimes people tend to do more projects to publish research articles. That is also kind of a bad practice, I would say. Most of the times you have to have a genuine enthusiasm to solving problems in that particular research domain that you are kind of dealing with. So Basically, through an innovative project, you can expand your knowledge, and you can add colors to your profile when you are kind of applying to a job or higher studies. People tend to believe that projects are only project only matter when it comes to going for a broad studies or higher studies. But I would, as per my experience in internships, and as per my experiences in other research assistant positions, I would say that is not true. And the projects that you are going, some companies only they ask for the projects that you have done. So projects, these kind of projects are important for the for getting high kind of emphasized, so getting highlighted in the job interviews as well. Yeah. Moving on, I think. This is kind of a illustration what may be a problem and how can we solve such a problem through a defined protocol. So as you can see, the long hospital queues are and indeed a problem in Sri Lanka. So it is kind of a obvious pressing societal problem. And it is actually the circumstances inside the hospitals are not particularly not suitable for elderly patients and disabled patients, because in lining with the those queues. We can, as an innovative approach, an innovative solution, we can suggest telehealth, but it is not totally new. The telehealth is already applied in several parts of the world, and it has been tested and it has been validated through several case studies as well. However, the problem here is not only applying the telehealth. It can be a part of the solution, but you have to make it suit to the local context. How can we kind of develop a more localized framework within a telehealth approach, so that it can suit to the Sri Lankan context? So that is one thing. So normally when it comes to the projects, the quality, safety, and cost matters. In an innovative project that you are going to do when you are participating for the Brainstorm competition and other academic projects as well, you have to think about the quality of your innovative project and the applicable safety measures and the cost as well. This is another problem that I would say. This is one of the problem that one of my teams have recently collaborated. So the adolescent depression. Adolescents are kind of people from children from year 10 to 19, as I would say. So the adolescent depression is kind of a burning question in several parts of the world, including Sri Lanka. So the current screening and diagnosis procedures for adolescent depression are more time consuming and cumbersome. They follow the old standard protocols that have been there for many decades. So, and they are highly dependent on clinical expertise. So we thought, why not an AI assisted gaming platform could be used as a novel and easily accessible screening tool. So we would replace through an AI assisted gaming platform to that cumbersome process, so that the adolescents are naturally inclined to do gamings, naturally inclined to play games. So through an AI assisted gaming platform, which mimics to identify the clinical characteristics of those adolescent depressed children, how can we kind of utilize such screening tool and for screening purposes? So that was our innovative solution. So it was among the top five solutions at Fall Asia 2022. It is Fuel Asia 22 is the Asia's largest university entrepreneurship program for health. Yeah. So in that particular problem, what we critically identified is the unmet needs that are currently not sufficiently addressed in the literature and the practice as well. So those kind of things also, apart from the quality, cost, quality and cost and safety, we can also address innovative projects in terms of unmet needs and error rectification. So in my undergraduate career, I have done several individual projects as well. But you don't sometimes the academic projects you are enforced to do group projects. That is also having a group which you can do researchers and do this kind of projects can be fun, and it is more challenging at sometimes. So it is more about dealing with people, social interaction as per se. So the soft skill part of yours should be high in those group projects. When you are dealing with yourself in an individual project, that is not concerned, of course. So when you are forming a group, I would recommend you to consider the interest of your group members. Normally, if I say when you're going to do a AI related projects, and your friend may be interested in more in hardware, and he has no expertise so interest in AI. So I would say only because he's your friend, do not get involved, do not form a group with him. So sometimes if he's willing to learn that, that is okay. If not, then that would be kind of conflicting for both of you. So if it is a kind of a AI assisted hardware device, then AI assisted hardware device for, let's say, ECG, then that's okay, because he has a different set of skills for hardware, and you have a different set of skills for AI. So you can both work together, and you may bring a different set of values, different set of skills, and he may also bring a different set of skills. Then you can integratively and collectively work. And one of the most important thing I would say is the responsibility and the commitment that your project partner shows in regard to the project is also critical, because if it is an academic project, it is kind of an enforcement. You have to do so. But if it is not a academic project, then that commitment and the responsibility do matter. Yeah. So after identifying the proper research problem, then you can reach out to potential supervisors and collaborators. Sometimes you do not have to follow this step. You can start the project with your own, and later, if needed, you can contact a supervisor or a collaborator. So if you contacted the supervisor or collaborator, I would say have a detailed discussion about the proceeding of the project, and if the idea is from yours, then you have to convince the supervisor about the feasibility and the innovative aspect of the project. If not, it is if the idea is from him or her, from the supervisor, then you have to be convinced enough about his or her idea, and then after those discussions, you can amend minor changes to your problem or your topic. And through those, normally when we come to the lecturers in our department and in our university, they are more collaborated with potential co-supervisors and collaborators all around the world. I would say that is also an invaluable path to your to the success of your project. Then then this is one of the most important part in the project, the feasibility study. So this feasibility study is is the thing that that would reveal whether your problem is really the problem to be solved given the existing constraints. So this before this study, before conducting this study, you only have an idea about your project and about kind of an rough idea, shallow idea about your concept. However, after this step, you may come through whether actually the idea from me or the supervisor is actually feasible. If it cannot be done in the current constraint, within the current constraint, then that is pointless to continue. So this is actually one of the most important part of your project. So you have to do a feasibility study, and it is kind of integrated with these 5 things: literature review, scope and objectives, and agreeable work division, timeline and plan, and the financial resources. So when it comes to the literature review, so what I recommend is find and summarize as much as possible research papers, especially the review papers and patents, articles, and so forth. Find as much as possible, and when you are reading a research paper, you do not have to read all the content of the research paper. Research papers may be having 20 to 30 pages, or 6 pages, or 4 pages, so as per se. So what you have to initially read is the abstract part, and the if possible the methodology part and the conclusion part. So when you're reading a research paper, do not consider it as a burden. It is an investment, of course. So just read the abstract and conclusion part and try to get the basic idea that what is the authors were trying to do. So in this regard, I would say the Google Scholar is the most extremely important tool as for now. So when you're kind of going through the Google Scholar, you can use your key. There are several filters, and you can use that. And if one of the most important thing that many people are forgetting is that when you select a research paper, the Google Scholar indicates what are the cited, what other papers have cited that particular paper. So through that loop, you can find many related papers. So not only using the search bar, you can use that particular option as well. Cited, it says cited by here, cited by. So then using that option also, you can find many related papers. So when you have found the research papers, you can use paper management or reference management tools such as Mendeley, Google Drive, and Zotero. So they will be useful in organizing these papers when you need to revisit again. So in this AI era, there are other extremely currently emerging tools as well, such as Elicit and Iris AI. They are more like more than having the reference management. They are also working as I think I recommend you to go to this Elicit.ai and Iris.ai. They are more like to multi-dimensional research document management platforms. They do not only as Elicit.ai, you can not only the keywords, you can also search for the NLP based limitations as well. You can just type a kind of keyword as limitations of that particular paper. Then the limitations of each paper would be entered into the table. That is kind of the power of AI in these days. Yeah, then as I have previously described, scope defines the boundaries of your project, and yeah, scope defines the boundaries of project, and the objectives define the critical milestones for the successful execution of your project. So you have to identify the difference between these two. So scope generally deals with which extent you hope to conduct your project, like the boundaries, what I would say, what kind of performance that I would expect from my system, from my AI model as per se. So that is my scope, and the objectives, I can say what are the things that I want to accomplish in the project after the successful completion. So normally what I recommend is when you're kind of finalizing these scopes and objectives, you may need to formulate them with your supervisors and collaborators. So since they have much better perspective about the feasibility and the area that you are dealing with. Yeah, then this is also one of the most important part, the work division. So in the feasibility study, you have to have a elementary idea about the work division. So sometimes in many projects that I have worked with, I basically my interest area aligns with the AI assisted medical instrumentation. So normally most of the projects that I worked on has two aspects, hardware and software. So most of the times these hardware and software can go parallel. They are more independent, and they are more independent, as I can say. So uh, so if they are independent, like in the hardware and software domains, so they can be executed parallelly. So you can assign if you have one person in if you have one person who is more aligned or interested in hardware, then uh, he or she can work on that particular part, and that division should be based on in the interest of that person, and the skill set and the potential workload that is related to that particular aspect. And then in the I would say in the middle of the project, or in the when you're moving on with the project, you may need to integrate collectively those two parts. So that can be done collectively, I would say. And then it is essentially needed to reevaluate and revise as you move on. So that can also be done collectively. So first you have to identify what are the, I would say, if that is a hardware software integrated project, some people can work on hardware part and some people can work on software part. And when it comes to the firmware part, or a kind of a mobile integration, the both parties can work together. So one of the most important part is you complete your assigned part. You have to complete your assigned part. That is mostly important for the success of the project. If you are lagging behind, or if you don't have a responsible response to the project, then the whole project would ruin, I would say. Then the budget and the timeline. The normally what we use is the Gantt chart for timelines, and the Gantt chart, as you can see in this graph, also it is kind of a it lists down the task that are needed to be completed, and the timeline and the time periods of that particular task that is going to be span. So that is normally there are several from Microsoft. There is a particular service for creating Gantt charts that can also be used, and there are the online tools as well for that. And the financial resources, and some projects need financial resources, some projects do not need, if it is a open source based software project. so they do not need financial resources. So I would say at the beginning of the feasibility study, you may need to select or kind of determine whether you are going to self-fund or find means to fund using several grant or funding schemes. The government research grants and organization funding schemes and university grants and industry collaborations are also there if you can apply. Then about the execution, that is the previous things that I have told about the feasibility study. And then when it comes to the execution, the simple principle is eat, implement, experiment, document, sleep, and reiterate. So this is the basic principle, I would say. When it comes to the implement part, you can start with reproducing the results from the previous literature review that you have found. So sometimes keep in mind that the simplest approach could be the best. So do not dive into complex approaches when you are starting the project. You can always start with the simplest approach and then go deeper. And then when it comes to the experiments, you may need to design experiment to verify the performance and validity and applicability. So these design experiments varies widely with your research domain. So it is not similar when it comes to the hardware. Come to hardware project, the design experiments are totally different from what when it comes to in compared to the software projects. So they are kind of dependent on the research domain that you are dealing with. So regardless of the experiment protocols, the documentation are literally the same for almost all the fields. So you have to record your methods, outcomes, and remarks. So possibly using MS Skills, Excel, or GitHub. So GitHub is a valuable resource when it comes to the version control and collaborating. So it is normally most of the open source projects are hosted in GitHub. So there are other alternatives as well, which is, I would say, the GitLab is more useful when it comes to the version control. And there are other options as well, such as Bitbucket. Yeah. Then the next step is reiterate. So as you know, engineering design cycle is the one that we as engineers mostly use for our design procedures. Ask, imagine, plan, create, and test. Those are the 5 steps in engineering design cycle. So through those steps, you can identify issues in the previous methods and design alternative methods to kind of eliminate the drawbacks of the previous method, so kind of eliminate the identified issues. And sometimes you can propose your own idea. That is, I would highly recommend such novel ideas, which are to be validated again through the reiteration process. And if those procedures are valid enough, you can proceed. Then I would say when it comes to the as I previously mentioned, experiments varies highly with the research domains. So as an example, one of the areas that I am more familiar with is kit and PCB design. So you can in this domain, you can always start with gearing up your background knowledge using the existing resources, such as existing these companies or these brands. They provide open source. They provide several open source circuit designs. So you can use them. You can use them to gear up your background knowledge in terms of electronics. So Texas Instruments, DigiKey Electronics, and Analog Devices are some such companies and some such organizations. So, and when it comes to the circuit design, first you have to identify what are the circuit requirements. So it may vary with the product that you are going to deal with. So signal acquisition and processing, power management, cost management, accuracy and safety, user ergonomics. These are some of the most common things that are dealing with when it comes to the circuit designs. As an example, I would say this is in this diagram, you can see one of the basic circuit block diagram that I have previously developed for one of my semester projects. So it is related to developing a electronic stethoscope. So in this particular design, what I have done is the signal acquisition and processing part. It is and the user ergonomic part. So it mainly deals with the preamplifier, a filter, and a power amplifier and ADC part. So then after identifying the circuit requirements, you have to build this kind of a basic circuit block diagram, which indicates the connections and the flow of your device. And then you can reiterate this process using several different components, sub-circuitry blocks, or you can reiterate the process and evaluate them using your theoretical knowledge or simulations, software-based simulations. And when you finally comes to the requirement, satisfied requirement, you can proceed to the prototyping part. So as I have mentioned something called visualizations. Visualizations are always powerful than the theoretical analysis. I would say they provide kind of a visual understanding of what you are going to do and what are the possible outputs from your circuit design. These are some multisim, multispice, and Proteus are some of the well-known simulation softwares. Using these simulations, you can minimize errors and evaluate the performance and reduce cost associated risk. And of course, it is a good learning. These are good learning tools. So I would say when I would recommend that when you are dealing with kind of a project, if particularly an electronic project relates to analog electronics domain, you can always start with these kind of visualization tools. They are really helpful for identifying the possible drawbacks and results, possible results that would occur through your projects, even before you are going to prototype them. So finalizing part, you can finalize the circuit design after evaluating each sub-circuitry levels. What I previously mentioned in that electronic stethoscope example, the filter is one sub-circuitry and amplifier is another sub-circuitry. So you can evaluate all of these separately and then as a whole circuit, and then you can complete the test spaces using the breadboard, and then after finalizing all these steps, you can evaluate the outcomes and go to the prototype part. So cost management is also critical when it comes to circuit designing. So you have to then after designing your full circuit, then you have to consider about the bill of materials and the target cost and the associated risk as well. Yeah. Then when it comes to the PCB design, that is another major part when it comes to the electronic designing as a whole. So PCB designing mainly comprises of schematics and board definitions, component placement and routing, and fabrication of PCB. So I would say these are more popular tools when it comes to the circuit design, PCB design, Altium, KiCad, and Eagle. So most of these tools are not to be taught, but to be learned. I would emphasize it again. They are not to be taught, but to be learned. So you have to practice them. You have to practice them as much as possible with you. So then only you can master them. They cannot kind of be taught and after one lesson you can learn all the things. So you have to, if you want to master them, you have to practice them. So in PCB design suggestions, I would say the neat and tidy schematics, and they are most important. If the schematic is a mess, then the PCB design is going to be a mess as well, most probably. So be mindful about the components and their capabilities. So simply you just keep in touch with the data sheets. You have to go through the datasheet again and again to identify their limitations and drawbacks as per se. So component placement and routing, if you have done an optimum component placement, then the routing would be easier. If you have done, if you haven't paid much attention into the component placement, then the routing would be hard, I would say. So, and always do DRC and ERC, design rule check and electrical rule check. So after completing all the steps, all the things that I have mentioned here in a successful manner, you can go forward with the PCB manufacturing part. These are some well-known two companies that do the PCB manufacturing. That is one research domain, how the experiments are happening in that particular research domain in PCB design and circuit design. When it comes to the machine learning research designs, as you can see, machine learning research designing are totally different from the hardware experiment designs protocols. So they are mostly dealing with data sets, feature extraction, and the model training and testing and the predictions. These particular steps may either relate to supervised machine learning, unsupervised machine learning, or reinforcement learning. So if there is a supervised task, as you know, the classification and regression are the most well-known supervised tasks. And in unsupervised tasks, the dimensional reduction and clustering are there, and the learning task and game AIs are in the reinforcement learning. So in deep learning, the feature extraction, the manual feature extraction part is bypassed by the network itself. So these are some. So as you can see, the pipeline for this particular part is completely different from hardware domain. That's why I say developing the experiment protocols are completely based on that particular subject domain. So these are some well-known dataset tools for dataset search. Kaggle, it is also a well-known dataset search tool, and Mandalay Data, Google Dataset, and Pisionet is more related to biomedical data, and there are the Fixia and driven data as well. So you always you do not have to start with the scratch. There are some existing works in the GitHub open source database or open source implementations, and you can find them using either I would say the papers with code is the most prominent code searching platform, I would say. And there are other paper searching platforms as well, such as Semantic Scholar, Google Scholar, and IEEE Explore database. Normally, when it comes to the machine learning projects, you need to have TPUs, graphical processing units, and tensor processing units. They are more computationally heavy tasks. So these platforms provide conditional or free computing sources: Google Colab, AWS, Amazon SageMaker, and GCP and GCP AI platform. So you can, as from your student accounts, you can either that is different from each company. However, most of the times they are providing free. The Google Colab is obviously providing free resources for a limited TPU and GPU access, and other using your studentship in the University of Moratuwa, you can you can kind of claim credits from other services as well. And the visualizations can be, when it comes to the visualizations, the testing and training validation plots can be generated inbuilt with these Streamlit, Plotly, and TensorBoard platforms, I would say frameworks. And the experiment tracking and organizing and logging can be done. This is also nice, since when you are dealing with the research problem in AI domain, you have to fine tune your hyperparameters. So you have to have a thorough record on what are the experiments that you have done. Then this experiment tracking tool such as Neptune AI, that is the one I am using. So they are most instrumental, I would say, since if you do not have a sufficient track of records of the experiments that you have compiled, then that would be a mess that would be a mess and a great loss when it comes to producing or compiling your final report or a final demonstration. So I would say these tools can be learned and should be learned, and you have to master them if you are going for AI research. And then I just described those AI research part and the hardware project domain to kind of differentiate the how different protocols experiments are going on with that two different fields. And apart from those experiments, you need to eat and sleep. It is critical that you keep yourself healthy and fit, since as we all know, health is wealth. So just take and enjoy breaks and appreciate your life outside of your work and project. So that is also important when it comes to your personal work-life balance. And it also will help you to mentally to have a fresh and clear mindset. Just go out with your friends or group colleagues or your family. That is also an instrumental part when it comes to kickstarting your project. Then for an academic project or a competition, you may need to do a final demonstration. You can always do progress reviews between yourself and with your with your supervisor or collaborator. So you can make sure to have a dedicated weekly or bi-weekly meeting slot, and be prepared. That is most important. So you have to have at least prepare a few slides to present your updates, so that everyone know what is the page that we are on. So they can relate to you, they can understand you, they will provide different perspectives and insights if all of you are on the same page. So that is highly beneficial for shaping your project. Then when it comes to the final demonstration, the demonstration can be different, from competition to competition or academic module to academic module. Sometimes you may need to compile a final report, or sometimes you may need to do a demonstrative presentation. So just here, it is the most important part is plan ahead. I would say repeat, plan ahead. So you have to have a if a final report is needed, you can always develop a compiler detailed final report. Most of the reports are compiled of these sections: introduction, methodology, experiments, results, discussion, and conclusion. Sometimes the template may be provided by the evaluation committee or the program committee as well, so you can refer to them as well. So if they are need for a demonstrative presentation, I would say make the presentation early as possible and then rehearse that. So always when you are dealing with or when you are developing a presentation, keep in mind that a picture is worth 1,000 words. So video may be worth 10,000 words. So if possible, make a video of your project that would actually worth 10,000 words. I would say most of the projects I have done, I always try to I try to compile a video so that the audience and the evaluation committee have a better understanding on what I am going to say or what I am saying. So I would say that is also one of the most important part. And another important factor that I want to emphasize is prepare as you're only given 3 minutes to pitch. So you will know what are the things that you need to talk about and what are the things that you are not needed to talk about. So I think all of you have heard of the 3-minute thesis. So prepare as such. So you know exactly what you want to tell and what are the subsequent matters that can be explained after the presentation or in the Q&A session. So always anticipate questions, because if there is an evaluation committee, they will definitely ask questions, and make some additional slides for them as well. Sometimes your project, if the project surpasses the state of the art means the best results as per now for that particular research problem. If your project surpasses the state of the art or has presented a significantly novel approach to address the same problem, I would say it is worthwhile to explore the paths of presenting your project in a publication such as journal, conferences, or forum, or even applying for patent. That would definitely add colors to your CV and your higher studies application or a job. If you have a publication in a reputed journal, or you have a patent for your project. So when it comes to the publishing research articles, so public research articles in journals, conferences, and forums, I would say there are different possible avenues, different conferences, thousands of conferences and journals out there. However, you have to, when you're publishing something, you have to find the conference or journal based on their H-index or impact factor. That would indicate how many the impact that conference or journal is going to have on that particular field. So you may not be kind of set aside from yourself to the important thing that you have done. So you have to select based on H-index and impact factor. And the Google Scholar Metrics and SciMago rankings, they are providing some excellent explanation about these H-index and impact factors, and they have kind of ranked all the conferences out there and all the journals out there, all the reputed journals and reputed conference out there based on their H-index and impact factor. So if you are going for a research publication, I would say from your project, I would say start with finding the best conferences and possible conferences and journals through these tools. And if you're going for a patent, I would say patent is provides a kind of a legal binding in which the invention can normally only be exploited with the authorization of the owner of the patent. So it is not open source. If someone wants to use your patent, then they have to have the authority from yourself. If not, you can sue them for violating the patent rights. The intellectual property laws are the governing laws in this particular arena. So I would say if you file for a patent, you have from the patent application date, you have the right to that particular patent for almost 20 years. So if you think your project or your invention has more commercial value and has more commercial credit, I would say go for a patent and try patent may be either it may be related to either completely novel concept or a novel procedure in a existing product, or a industrial applicability in a novel manner. All those three factors, complete novelty and the process novelty and the industrial novelty, are all those three factors are considered when it comes to patents. These are possible patent searching platforms: Patent Scope, USPTO, US Patent Office, and Lens, and the Google Patent. So these are kind of publicly available data sets for patents, and there are other patent searching databases as well, which are commercial, such as Innovation Q Plus. So normally, even if you think that your publication or your patent draft or your project in total, they have excellent credit and excellent novelty, sometimes that novelty could not be identified or could not be grasped by the evaluation committees. So if available, if you are not if you are not capable enough to systematically pipeline that novelty into your application through the drafting and the submission procedure, then that would be a definite waste. So I would say, when you are kind of drafting or writing a research paper or drafting a patent application, I would say, even if the project is not supervised by someone, I would say go for a supervisor or collaborator and who has much experience in such avenues, and get their guidance for your writing and drafting and public submission procedures. Then you will not get into a pitfall that should not have been caught. And even if that is the case, if you failed on publishing your research paper, or if the paper or the patent is rejected, don't worry. It is okay and always possible things don't go as you plan. So just step back and reiterate again until you improve your outcomes. Apart from the tools that I have previously mentioned, these are some other tools that I would recommend. This VS Code is essentially important for organizing work in coding projects, especially in coding projects. MATLAB is kind of a multi-modal program environment. You can use it for signal processing, electronics, and telecommunication applications. And Overleaf is kind of a LaTeX-based environment, in which multiple users can collaborate to draft research articles mainly. And MS Office is also through your UM credentials, you can access MS Office services. I think you are more familiar with that. And Canva is kind of useful for infographics. I have compiled this presentation using Canva. And Slack is more into developing collaborative platforms, more into providing a collaborative platform for group projects. And these are some other innovative AI projects, AI tools that have previously been emerged. This chat GPT, it is a novel tool. GPT means generative pre-trained transformer. So it is from OpenAI, and it uses NLP in its backend, in its NLP techniques. And BitAI is kind of a multimodal, multidimensional research collaboration platforms. Most of the previous tools, such as Google Scholar, and those are also AI backed. However, those are only related to particular, let's say, for query searching and tasks like that. However, this BitAI is kind of more into multidimensional document collaborations. It can work with several document types and several data types. So it is also becoming a novel research platform, which is backed by AI. And E-Link is also it is used for instantly saving content from web using an interface. So recently I have identified that these two companies, BitAI and elink.io, they have collaboratively developed a platform as well. They are kind of interconnected. Before this presentation, I didn't usually go into much into AI backed tools. However, I have asked one of my friends to type this sentence at chat GPT. So the question is, what would be the future? What would be some future biomedical inventions to disrupt the healthcare industry? So I am impressed that the ChatGPT has kind of listed out five different things that are actually revolutionizing the biomedical and healthcare industry. So gene editing, personalized medicine, telemedicine, and artificial intelligence in healthcare, and 3D printing, which is related to cell biology. Sometimes these AI-based platforms are more into I would say more into more based on the data set variance, and they have more positive bias, I would say. Sometimes they are more useful to identify some of the latest trends in the world. That would be interesting. Then these are some personal traits I would recommend all of the participants to get used to if you want to self-improve. Finding your passionate area may need some time indeed. I have also invested several years of my life to find my passionate area, and believe that it is you need best of us need to have some time to identify his or her passionate area. So be open to that, and until that, you can always interact with research conferences and research avenues and different projects. Such you can refer to these reputed journals: Nature, NeurIPS, CVPR, EMBC. You can also find using the Google Scholar metrics. You can find what are the top conferences or journals in your particular interested area. So just follow them. Sometimes you may need to not to understand everything in those research papers. Just go through and try to understand as much as possible. Then as one of my friends, he do not like reading, and it is also okay. You can always try to listen to podcasts and use YouTube discussions. That is, I would say, find best ones from best people, because when it comes to the social media, all things that are in social media are not true. So find a reputed YouTube channel or podcast. I would say these AI Today and the Lex Friedman's AI podcast are one of the best that I'm also following. So and you can also follow several YouTube channels and topic groups, such as this 2 minutes paper. It is a YouTube channel, so you can use those. You can follow those YouTube channels, and if you are not into reading. So other than that, you can also always follow online courses like in Coursera and edX and Udemy platforms, and you can also follow several social media groups, such as this machine learning group at EPFL. So soft skills, as I recommend, skills are as important as the logical and analytical skills. So always be curious. Try to always be open to learning new topics and things, and always be flexible, because the challenges are waiting for you. And when you are dealing with a challenging project, that there are definitely so many challenges, so you have to be flexible and compromise yourself, and you have to be adaptable. And and apart from your logical and analytical skills, I would say always have try to develop your presentation and communication skills. They need also they I would say they need some time. They need sometimes to develop as well. So don't try to overcome these presentations and communication. Don't expect them to be raised within yourself from overnight. That is not going to happen. You have to practice again and again. You have to be open to your mistakes, and do the apart from those mistakes, try to be a better version of yourself when it comes to these skills. And the management skills are also important when it comes to a project implementation. You have limited resources in time, efforts, and human. So you have to properly manage these resources for a successful project implementation. And apart from the importance of project identifying the correct research problem, the most important other part of the project is project implementation part is the consistency. I have seen many projects in my undergraduate career who has not who which are kind of halted due to having inconsistency. So this inconsistency matters a lot. I would repeat it again. Consistency matters a lot. You can start always. You can start, and even after 1 month or 2 months, you may give up the idea because of you are not getting in touch, and you have other commitments as well. I would say the most important strategy to have consistency in your project is set by weekly or bi-weekly minor goals. So you have through your scope and objectives, you have the major goals. So set weekly or bi-weekly minor goals to achieve. So it will keep the momentum of your project. And finally, these minor achievements will lead to a steady approach to a major goal. So I would emphasize again, consistency matters a lot when it comes to a project implementation. So set minor goals. That's the strategy that I have identified throughout my undergraduate career in project implementations. And sometimes it is okay to challenge the norms, to pursue seemingly insane ideas. So sometimes this is not always right, I would say. However, sometimes this is true. So you can always follow your gut, and you can either succeed or expand your learning. After taking such challenging norm, after taking some challenging idea, I would say if you hit a dead end, just don't worry, because it happens the best of us. No, there is no particular person in the history of humankind who has never failed. So just take a break and relax and step back and reevaluate your methodology, and if possible, revise its error. You can always get help from your supervisors, if any, or your peers. And even after that steps, if we're still unsuccessful, I think just leave it there. Don't worry at all. You have, I would emphasize this. You already expanded your learning curve and found a pitfall to never step on again. So be happy that you have found a pitfall to never step on again. As my final remarks, I would say for a successful project's completion, as I have emphasized throughout my presentation, two things I would recommend highly, and I would emphasize highly. First one is the identify the correct research problem, the research problem. From my previous experience and from my previous experience in various projects, I would say this is I would 20 to 40% of the time I would spend my time on finding the right research problem, and then other most important part is the consistency in implementation. For that, I have previously said that the strategy of mine is just set minor goals, then you will keep your momentum, and always be curious, flexible, and adaptable, and follow your gut. Sometimes it is okay to follow your gut, and most importantly, don't forget your life outside the project and works. Good luck.